Number 1 exists. I'm not rereading it. It's there for all the people if they want to read it. His simplification of the expression is shown below. So step 1. In step 1, you have to figure out what they did and see if it makes sense. So they took a 2 out of the top. Take a 2 out of 2x is x. Take a 2 out of 10, you get 5. So I got 2 and then x plus 5. The bottom, they took a 2 out. And then they were left with x squared minus 25, which is correct. And then they crossed the 2's off and they did 1s. Doesn't matter that I probably would have went and did difference of squares first, then canceled. Does that matter? No. The person still did an error in what they did. They just didn't do it in the order that I would have done it, but it's not wrong. So the 2's cancel off and they put 1s. Then in the next step, they did a difference of squares. X plus 5, x minus 5. So this was good, and that's still good, right? So we're still good there. We agree? Then in the next step, they canceled off the x plus 5. Is anything wrong with that? No. So that step's still good. Step 4. What happened? We're missing the 1 on the top, right? There's still a 1 up here. So this needs to be 1 over x minus 5. So they errored technically between 3 and 4, correct? So then 4 is the error. Does that make more sense how to state where the error exists? If it's between 2 steps, you always pick the last step, not the one, not the first one. Okay. Number 2. Sandra and David both simplified the expression x over x squared plus x. These both were on diplomas in the past, just so you know. Their work is shown below. So let's look at Sandra first. So Sandra's like, hey, GCF, difference of squares. So can't do anything to the top. So we could put it in brackets if we wanted to. Take out an x, and we're left with x plus 1. That's good. They canceled these off. She was left with a 1. Yay. Good job. This one, oh, scared. I thought I was choking. I'm okay. Phew. The next one, this person did something that is correct, but the weirdest way possible. I would not suggest it. They just went, hey, I can take an x out of everything. So they took an x out of here, an x out of here, and an x out of here, instead of taking the GCF of the x out. It works, but so many errors come from this, because people think they can take x's out of places they can't. It takes that whole, like, cross it off. The only reason why they can do it is because this term still had an x as well, right, the bottom term. If this was like x squared plus 1 on the bottom, they could not just cancel off, right? But they did. They got the right answer. So in here does not lie the problem. These are good. But we always have to read the entire box, correct? In math, just so you know, there's never anything extra. If it's there for a reason. I heard in some sciences they like put some extra information in there sometimes. Like you have to read through someone's life before they get to the table and then get set. That doesn't happen in math. If it's there, it's there for a reason. Okay? So Sandra stated that the non-permissible values of x for the equivalent rational expressions are -1 and 0. David stated that the non-permissible values of x for the equivalent rational is -1. When do I have to state non-permissible values? Yeah. Second step. Before I do what? Or I cancel anything off, correct? So David stated non-permissible values of what's left on the bottom, didn't he? Sandra actually stated NPVs before she canceled. So she's right. This would be 0. And this one would have been. So it's going to be Sandra. Now it says, which student is correct? Justify your choice. If you don't, I don't know why it's, join me now. If you don't justify your choice, you're not getting the marks. There will be justifies, explains, compares, stuff like that on your diploma. If you don't do it, you will lose almost all the marks, okay? Now you have 2 written response on your diploma. Each written response has 4 bullets. One of the bullets is worth 1, and the other 3 are worth 2. So each question is actually out of 7. Okay? The bullets can be connected in information, but they're not connected in numbers. So say you go to number 1 and you make a mistake in your math, the next bullet isn't based off of that previous bullet's math. So you can't get, like, hit up twice for making something error. Okay? So which student is correct? Sanja is correct. Which if this bullet was out of 2 marks, you'd get 1 if you stopped there. Because you didn't justify, right? You just answered one part of it. Sanja is correct because Sanja stated all of the non-permissible values before she canceled like terms. So a lot of your daily quiz will contain past diploma questions, so you know what they're going to look like. You can see the kind of style of way they ask it. It's not just like simplify and then this, right? Because most of it's multiple choice and numeric response, and then you have 2 written. All right, make sure you go back to your notes. So we're at the your turn, the one between example 2 and example 3. So we're just simplifying of basically one rational number, or one rational expression, and then we're going to do multiplying and dividing. Multiplying and dividing of rationals is extremely easy if you can do simplifying. If you can do simplifying, multiplying and dividing is easy, like stupid easy. If you can't simplify, it's just like simplifying on steroids, basically, and you're not going to do it. Okay? So we should be really good at simplifying, so when we add multiplying and dividing, we rock at it. Right, Reese? Yeah. Okay. What did I do with my marker? I can't even walk anywhere. It's impossible. Oh, I made it under. Okay. So, let's look at the first one. So it says simplify the following rational expression and state non-permissible values. Even if I don't ask you to state them, you do, right? You might as well. You're really good at it. So 24x squared plus 12x. Can I take anything out of that? A 12 and a what? A 12 and an x. So I can take out a 12 and an x, and then I go 24x squared divided by 12x is 2x. And what's 12x divided by 12x? A really large 1. It doesn't just go away. And this 12 and this x can go in their own brackets. So make sure you watch that. It's 2x plus 1, right? Plus 1. If you let it drop off, give yourself a little side note. Highlight it. Remind yourself to not do that, right? Because that's going to be common error. Then on the bottom, I have a 3 and an x. So before I go, step 1 is GCF, difference of squares. Step 2 is state NPVs or restrictions, non-permissible values, right? Does a 3 get me a non-permissible value? No. Does the x? Yes. What is it? It's x cannot equal 0, and it's already by itself. So yay, we're done, right? So step 1, GCF, difference of squares. Step 2, non-permissible value. Step 3, cancel. Is there anything on the top and the bottom that can cancel? Yes. What? You can take a 3 out of the 12 and the 3, and the x's. Now, this 2x plus 1 has two-sided tape in between it, right? So 2x and the 1 are attached together. Is there a 2x plus 1 in the bottom? No. That baby's staying, right? There's no way 2x plus 1 is going away unless it has a replica twin in the bottom. Does it? No. Staying for life. Then I look at my x's. Hey, I have 1x and I have 1x. I can do a 1-for-1 special, so those ones can cancel. And then when these just are numbers, they don't have anything attached to them, right? They're just numbers. I say, is there something I can take out of both? I can take out a 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So we have a 1 times 1 times 1 in the bottom. Do we need a 1 in the denominator? Do we have to show the 1? No. Would we actually be wrong if we put a 1? No, because every number is over 1. 4 over 1, 5 over 1, 7 over 1. So we can write it over 1. And then 4, and then 2x plus 1 over 1. But I don't need that, right? So I can write 4 bracket 2x plus 1. And then x can't equal 0. Okay, pencils down. We're paying attention because this diploma sometimes messes you guys up this way. Okay, pencils down. I need all of your attention, McLemmon. All of your attention. Okay? So on the diploma, it sometimes will say simplify this. Yeah? And it'll say in the form blah. And then it wants a numeric response. So sometimes it'll say simplify this expression into the form a bx plus c. Determine the value of a, b, respectively. Respectively means it has to be in that order. So say they just say a, b, respectively. My numeric response would be 4, 2, right? A, b, respectively. Does that make sense? This makes me happy because it's simplified and we have to simplify and we're in simplified form, correct? Sometimes, however, they'll go in the form ax plus b. The values of a, b, respectively. Is this currently the 4 bracket 2x plus 1 in that form? Is it? No, because this one has brackets. That one does not. So actually, to give that answer properly, you have to distribute the 4 back in, which is not in simplified form in my brain, but sometimes it comes up in that way. So what would I have to do before I gave the answer? I'd have to say it's 8x plus 4, right? It's 8x plus 4. So a, b, respectively, in this case, would be 8 fourths. Do you see the difference? You have to make your simplified form match their form that they gave you. So when I gave you the form with brackets, we went 4, 2, correct? Because it was a bracket bx plus c. So then we went 4, 2. But if I take the brackets away and I say it has to be ax plus b, you have to make the brackets go away so you can give a and b. Does that make sense? You need to make your solution match their solution. Okay? You can pick your pencils back up. All right. When we look at b, what can we take out of the top? A 2. And then we're left with x minus 3 because we're dividing it. 2x divided by 2 is x. Negative 6 divided by 2 is negative 3. And the 2 can go in its own brackets because it's just sitting out front. Then the denominator, what can I take out? What can we take out of it? A 3 and 27. What can you divide out of both of them? A 3. 3x squared, take out a 3. I'm left with x squared minus 27 divided by 3 is 9. Now, what is this? Yeah. A difference of squares. Because x squared, the square root of that's x, 9, the square root of that is 3, and there's a difference sign in between. What if there was a plus sign in between? You'd just be like Elsa and you'd let it go, because there's nothing you can do to it. Okay? It would just say x squared plus 9. Couldn't make it any better. And you'd get no NPVs, remember? Because x squared plus 9 is an addition of squares, and you don't get any NPVs. So the top, we get 2, x minus 3. And the bottom, we would get 3, and then 2 brackets. The front of each bracket, I get x, because the square root of x squared is x. Back of each bracket, I take square root of 9, which is 3. And I do plus minus. Now, what do we have to do first before we... I see 2x minus 3. I'm getting excited because I'm like, I'm not stupid. There's something matching. This is going well. That's what I'm thinking. And I really badly want to cancel. Before I cancel, Emily, what do we do? You have to state the non-permissible values, the NPVs. So, it's aggressive out there. Someone is winning. Okay. Does 3 get me a non-permissible value, the number 3? No. You go 3 cannot equal 0. It'd be a true statement. We'd be great. We'd be awesome. But 0 is not a non-permissible value here, is it? Is 0 a non-permissible value? No. Because in order for 0 to be a non-permissible value, I have to have just like an x or an x squared or an x cubed sitting here, and I don't have one. So 0 is not a non-permissible value here. However, x plus 3 cannot equal 0. Use the 3 over, so x cannot equal negative 3. And x minus 3 cannot equal 0. Move the 3 over, x cannot equal 3. Those are my NPVs. Once I've stated my non-permissible values, what can I do? Cancel. So the x minus 3's cross off, and I'm left with 2 on the top over 3x plus 3. In the very last step, the 2 and the 3 don't have to go in brackets anymore, right? There's nothing else I can simplify. If you put them in brackets, you're not wrong. The multiple choice answers just won't have the brackets, okay? So just be prepared for that. And then behind it, we state x cannot equal plus or minus 3. We're going to look at C. What can I take out of the top? Three. I know you all know it, but no one's answering. It's a 3. And I have the equal sign because I'm running down the left side because it's an expression. So take a 3 out, and I'm left with x plus 4. And then x squared minus 16 is x plus 4, x minus 4, because it's a difference of squares, because the square root of x squared is x, because the square root of 16 is 16, and there's a minus sign in between, so I have a plus and a minus. Yeah? Before I cancel, I see there's some things that match, but I have to stop myself and be like, no, I must state NPVs. So I'm going to go x plus 4 cannot equal 0. Subtract 4. X cannot equal negative 4. And then x minus 4 cannot equal 0 at 4. X cannot equal 4. Now, because I stated my NPVs, I can cancel. X plus 4's cancel, and I'm left with 3 over x minus 4. X cannot equal plus or minus 4. How'd you do on those? I don't care how you did yesterday. How do you do now? Do you feel okay with it? All right. Thumbs up if you feel okay. You can do really small thumb if you really want. Okay. So, we're going to look at example 3 right below it. We're going to look at A. A is going to be a thing. I would star A. I would star A because A contains information that everyone forgets about. Okay? So I'm going to star it. I would highlight it. I would put a pink highlighter on it. That's what I would do if I had my pink highlighter near me. I would highlight it. So, I have on the top C minus 4. Can I take anything out of it? No. So I'm just going to rewrite it in brackets. Because the C and the 4 are attached by two-sided tape, right? They're attached. The bottom, I have 4 minus C. Do I not? Everyone paying attention? 4 minus C. Can I take anything out of that? Doesn't look like it, so I'm just going to write it in brackets. Okay, is everyone paying attention? We did this yesterday. We talked about this yesterday. I told you that letters can be out of order with numbers, correct? The key thing, though, is that you take the sign that's in front of it with it. So I see the top is C minus 4. I see the bottom is 4 minus C. I want them to actually look kind of in the same order so I can see if they look the same, because right now they seem confusing to me. So I'm going to leave. I like having the variable first. It's like a thing I like. I don't know why. It's like order of, I don't know. That's how I go. Okay? So I'm going to leave the top one because I like seeing the variable first. C minus 4. The bottom, I want to write variable then number. So what am I going to write? Yeah, negative C, because that's a sign with it. And then what? Plus 4. What do you see between these two? Yeah. Yeah, what else? Yeah. The 4 on the top is negative, the 4 on the bottom is positive. They're the exact same but wrong signs, aren't they? Like exact same, and both of them are the wrong signs. If only one's the wrong sign, there's nothing I can do, they will never match. Okay? So if the bottom was like negative c minus 4, one of them would be the right sign, one would be the wrong sign, that's a problem. But if they are both the wrong sign, that's an easy fix. I can take a negative 1 out. If I take a negative 1 out of either of them, I will flop the signs, and their signs will be the same. Correct? Easy fix, taking a negative out. So let's look. So I'm going to leave the top one, because I like it better. I don't know why. But I could take a negative 1 out of this one, too. It wouldn't matter. So I'm going to go c minus 4. And in the bottom, I'm going to take out a negative 1. What does taking a negative 1 out do? Just changes the signs, right? And I just said these are the exact same but wrong signs, correct? So if I take a negative 1 out, this is going to become a positive c minus 4. Ah! They match. So I told you to star this because this happens a lot. You will get two that look exactly the same, but wrong signs. And all you need to do is take a negative 1 out. But like I told you, both signs have to be wrong. If one sign's wrong and one sign's right, there's nothing you can do to make them match. They will just never match. They will never cancel off. Life is good. That's how it is. Okay? Now I see they match. I'm super excited. I want to cancel them off, but I have to do what first? Make lemon? And PVs. So we're going to go c minus 4 cannot equal 0. Add my 4 over. A whole bunch of people were right. You all said restrictions and non-permissible values and PVs. So c cannot equal 4. I've stated my non-permissible value. I'm happy. Now I can do what? Cancel. And when I cancel, this one cancels off because it matches, they're twinning. But when I cancel, those slash lines are literally just ones, right? They just don't look like ones. They look like slashes, but they're really just vertical ones. I'm just making them look more like a 1 now. So what do I have in the top? 1. What do I have in the bottom? Negative 1 times 1. Negative 1. So I have 1 over negative 1, which I can actually write as negative 1. And then c cannot equal 4. So a whole bunch of people will get to the negative 1, and then they'll say there's no non-permissible values, because they don't state the non-permissible values before they cancel. So if you look here, it looks like there's nothing in my denominator. There's no variables, right? But back here there was, and therefore I need to state non-permissible values before I cancel. Okay? All right. We're going to move ahead to multiplication, because it's just going to use simplification. If you can simplify, multiplying is no joke, super easy, like crazy easy, because it is just simplifying with more stuff. So we're going to go ahead to here, multiplying. We're not even going to read these steps. You can go back and read them all you want after. I don't really care. All we're going to do for multiplying, it's going to say simplify. How are we going to know we have to multiply? It will have a multiplication symbol. Most of the time their multiplication symbol is not an X, because a multiplication symbol that's an X looks like an X, and most often they use variables that are X's, and it just gets really confusing, right? So most often they will use a dot. Or sometimes they'll do this. A bracket touching a bracket. A bracket touching a bracket is just multiplication, right? And it's because they don't want to use the X for multiplication because it looks like an X. So, all I have right now, don't let multiplication make you be like, oh my goodness, I'm multiplying. Same thing. I just have 2 statements now. I have 2 rationals to simplify instead of just 1, right? I have 1 rational on the left side of the multiplication, and I have 1 rational on the right. I'm going to simplify them just like I did yesterday. So, I'm going to look at the left one. X plus 1 over x plus 3. I go to the top. The x plus 1. Can I take anything out? No. So I just, are they two-sided tape together? The x and the 1? Yep. So how do I show that? Brackets. So I still have an equal sign running down the left side because it's an expression. I'm going to go x plus 1, show that they're stuck together. On the bottom, I have an x plus 3. Can I take anything out of it? Is it a difference of squares? Nope. It's simplified as low as it can go. So what am I going to do? I'm going to go x plus 3, and I'm going to put brackets. Then I'm going to show the multiplication symbol because I like it better that way. Okay, top right. Can I do anything? What can I take out? A 2. 2x divided by 2 is x, plus sign. 6 divided by 2 is 3. I put my 2 in brackets. Bottom, denominator on the right-hand side. Is there anything I can take out? An x. X squared divided by x is x, plus, what's x divided by x? Really big 1. Because if I'm taking a GCF out of x squared plus x, I better still have 2 terms, right? So it's a 1, and then I put brackets. It's an aggressive amount of yelling and a helicopter. It sounds like we're in a war zone. We're just not. Oh, there's another one. No, we're just near the airport in Okotoks, right? So. No, we're just near the Okotoks airport. What do I have to do before I cancel? NPV is what's the difference between this day, what's the difference between right now and a couple seconds ago? We have 3. We have more. We just have 2 denominators instead of 1, right? So we have x plus 3, x and x plus 1. That's it. It's nothing crazy, nothing big time from yesterday, right? We just have 2 simplifying instead of 1. So we're going to have to go x plus 3 cannot equal 0. Subtract 3. X cannot equal negative 3. And then we have x cannot equal 0 because it's by itself. And then we have x plus 1 cannot equal 0. X cannot equal negative 1. Now, when we multiplied fractions, way back in the day, we just multiplied top times top, bottom times bottom. Some people want to cross multiply. You only cross multiply across an equal sign. So if like you had a fraction equals a fraction, then you could cross multiply. Remember that was when it was allowed because you'd bring the denominator up, bring the other denominator up. Cross multiplying happens over an equal sign. Is there an equal sign in this question? No, I made an equal sign because it's an expression. This equals this, right? So I multiply top times top, bottom times bottom. So once I get to this spot, once I have stated NPVs, once I've simplified, I can just do this. It's just a really large simplification. I just draw a line straight across. Both numerators join, both denominators join. You see that? So you just, yep, right across that multiplication symbol. You just connect them. Now anything on the top that matches can cancel anything on the bottom that matches. Is there anything on top and bottom that match? Great. I'm just going to Braden instead of Bryden. Didn't even go with your brother's name. Okay, yep, Bryden. X plus 1 and x plus 1, x plus 3 and x plus 3. Then I have a 2 left over without a number on the bottom. There's no numbers down there. And then an x on the bottom with no x's on the top. So can I cancel anything there? No. It's as good as it gets. So now I have 2 on the top over x on the bottom. And then x can't equal negative 3, negative 1, 0. Is this very different from yesterday? No, I just have 2 simplification rationals in 1 question, right? And they can join after I simplify them. All right? You try B. What can we do to the top left? Question. The numerator on the top? Nothing. So we can just put it in brackets. So we're going to go 12 and x cubed. The left denominator, I can take out a, yeah, what's up? Yep. You can go x cubed, instead of writing it as an x cubed, you can go an x times an x times an x. Yes. Because some people find it easier because then it's easier to cancel off. The bottom, I can take a 3 and an x out. The denominator on the left. And I'm left with x plus 2 times the top. I can take out a 4 and an x squared. If you want, you can write 4 and x times x instead of x squared. It's easier, right? And then what's left over, when you take a 4x squared out of 4x cubed, you're left with x plus 8x squared. Take out a 4x squared, you're left with a 2. And on the bottom, a 5. And before I cancel anything off, I have to put the non-permissible values, right? Does a 3 give me a non-permissible value? No. X is just going to be x can't equal 0. And then I take x plus 2 and set it not equal to 0. And I subtract 2 from both sides, and I get x cannot equal -2. Can the 5 give me a non-permissible value? No. So once I've stated them, I can, this is to a 1, just so you know, because I expanded them. Now I can cancel. So it's an x for an x. So I'm going to draw my whole line, right, across. And now it's 1x for 1x. So I can take this x out for this one, or I could take an x out beside the 4 for that one. But I can't do like a 2 for 1, right? 1 across the whole top can take out 1 across the whole bottom. Then the x plus 2's cancel. And then sometimes it's harder for people to see that things cancel. So the 12 and the 3, you could take a 3 out of both of them, right? If you don't see that, you could put the 12 and the 4 together and make 48, 3 and the 5 together make 15, and then cancel in the next step as well, if that's easier. Sometimes that is. But I see this 12 and this 3, and I know I can take a 3 out of both. So 3 divided by 3 is 1. 12 divided by 3 is 4. And then I think I'm reduced. If I'm not, if there's more numbers I could take out, I might just do another step and cross off more, right? Which is totally fine. I think I have everything canceled off. I can cancel. So I have 4 times 1 times 1 times 4, so I have 16 on the top. And then I have an x times an x times an x times an x, which is an x to the 4. Over 1 times 1 times 1 times 1 times 5, so over a 5. And then I check at the last step, 16 and 5. Can I take anything out of both of those? Can I reduce that at all? No. So I know I'm as low as I can go. Say I didn't reduce. Say I did 48 over 15. Well, then I would know that I could take a 3 out of both of them and I've reduced again. It's not a big deal if you have to take extra steps to reduce, right? So if you miss a reducing, and you get to the next step and you see you can take more out, then go ahead. And don't forget to go that x cannot equal 0 and -2. Then we're going to look at C. The numerator in C on the left, I can take out a 2x squared. I'm not going to do it in one step this time, I'm going to do it in two. So I can take out a 2x squared, so 2 and an x squared. And I'm left with 2x cubed, take out 2x squared is an x, minus 4x squared, take out a 2x squared is 2, over 3x squared minus 9x, I can take out a 3 and an x. When I take 3x out of 3x squared, I'm just left with an x. Minus 9x divided by 3x is 3. Times I have an x squared. There's nothing I can do to it, so I just leave it as an x squared. And then x squared minus 4 is the difference of squares. And if you come along and you go to do question and like barely anything cancels, think I'm probably missing a difference of squares, because that's usually what happens. So if barely anything cancels off and you're left with this big convoluted rational, sometimes you just are, but a lot of the time you're missing a non-permissible, you're missing a difference of squares. So this here, x squared minus 4, square root of x squared is x, square root of 4 is 2, plus minus. Then I can state non-permissible values. Does 3 get me an NPV? No. What about x? Yeah. So x cannot equal 0. Then I have x minus 3 cannot equal 0. X cannot equal 3. You add it over. X plus 2 cannot equal 0. X cannot equal -2. And x minus 2 cannot equal 0. X cannot equal 2. Now, if you want to, like Amelia said, you can actually go back and like these x squareds, if you want to, you can write them out as separate x's. And for some people, that is substantially easier. So I'm going to show that step. So I could go 2 and an x and an x and an x minus 2 over 3 x minus 3 times x and an x and then x plus 2 x minus 2. Now with multiplication, I can write it, just draw a line straight through, right? And then it's a 1 for 1. So the x minus 2's cancel off. And then 1x for 1x. I'm going to prove that I can do this x with this x. It doesn't really matter. You could have went that x with that x, right? It's just 1 for 1. Is there anything else I can cancel? Some people want to cross off x's. This x minus 3 has to match up top. Is there a matching one? No. X plus 2. Is there a twin up top? No. 2 and 3? No. I can't make it any better. So now I can just put them together. So on the top, I'm going to get 2. And then an x times an x times a 1 times a 1 times an x is x cubed, because there's 3 x's. On the bottom, I have a 3. X minus 3. X plus 2. And then I state my non-permissible values. X cannot equal 0, 3, plus or minus 2. We're not going to worry about the your turn. You're going to go to your textbook. I still have to post the online one. Oh, my textbooks are at home. Do you have your textbook with you? I'll take a picture of it and post it as well if you don't. But someone have a textbook with them? Can I see yours? Under my desk at home. So we're in chapter 4. We're going to work on page 238. Number 3 AD. For A, 5A. A hint with 5A is you're going to have to take a -1 out to make the match. There's going to be 2 that look the same but wrong signs. So you take a -1 out of one of them, not both of them, or you're going to swap signs. That's for 5A. And 6. Oh. Just going to take a picture of them and post them to Classroom. I believe in you. I think you two can go together and make it.
We're not going to go together.
No, I mean like at the same time. I believe in you. I don't get why we don't really sit 12s together. I feel like we can make it.
I have a question. Is that a lecture?
6 all.
Oh,
It does look like an 11. But it's all the letters. Okay, I'm going to post each question. Autocorrected. Stop it. I'll just go 6A to E. So if you don't have your textbook, I just posted the 2 pages to Google Classroom. Yes. So to the library, you know where the library is. You know where the library is. Big glassy thing right below us. Ask for the Principles of Math 12, and it looks like, can you show them what it looks like? It's actually, it looks like a kite, but it's actually a whole bunch of parachuters. And I don't know why. Yeah, that. So it's Principles of Math 12. So if it doesn't look like that, don't take it out. Make sure you're working on your math, not your social life. I'll be here all week. By choice. I'm kind of not.
I'm forced to be here.
I'm kind of forced, but not really. Like I signed a contract to be here. It was by choice. I signed it in 2006, but you know, it was a wee bit ago. Make sure when you're done, check your answers. Also, if I just see a question with an answer, I know you just wrote the answer. That's not helpful to anyone.
No,
You could just go technically 25 times x times x times x. They're all monomials. None of them are attached.
and then the top and the bottom like circle. You physically can't take anything out of any.
Yeah, like you're gonna go negative 15 wide on the top.
Oh, right, you just.
And then on the bottom is 25 y4. Oh, that's really oh. Time. 6y on the top. Or 1. So your only MPV is gonna, this isn't gonna get you 1, this is gonna get you 1, this is gonna get you y can equal 0 4 times, so I'm gonna stay at 1. And then y for y, y for y. Take a 5 out of both of these. So I'm gonna get negative 3. 5. Because none of these have plus or minus signs attaching them together, right? They're all monomials. So on the top, I would get negative 3 times 6, which is negative 18. The y's all cancel over 5 y squared. Does that make sense? Yeah, the monomials are actually done worse. I give you these big convoluted ones with like different squares, GCFs and everything, and people will get them right, and then I give monomials, and everyone's like, has to be harder. So these ones were done worse. I like how she's not bringing them up. Alexa's giving them to you to make towers. Is it to get you to put them away? There's like 4 more steps, man. It's your turn. Sharing. Sharing is caring, you know? I would say. Sharing is caring. You still have 10 minutes.
No, don't say that.
You do.
So long.
10 minutes. tomorrow I'll be looking at this, seeing if you're doing your work. Remember, I don't often do homework, but when I do, I will. I'm gonna look and see if you actually talk to them. Because there's new people who get free shops, really, for that, and then be like, let's go. You're gonna put in your new homework Friday. It's just easy for me to check it in anyway, okay? The last year we were so much online and offline and online, and I actually sick to one method that I knew it over for. No, I'm getting it back. I'm just looking at it. Back. I don't want it. Sorry.
Same for
Yeah. Remember, your homework is due on Friday. However, I will look and see that you attempted some of it tomorrow, because if not, you're just sucking up my oxygen. And oxygen ain't free around here, people. It ain't free. I will start charging you 10 cents a minute. I make lots of money with my free oxygen that doesn't cost me anything. Oh, I posted already. Why was I right? Well, that's one. You can order the other.
Oh, okay.
So when that negative sign sitting out front, just put it to whatever fits it. I would put the top myself.
Okay.
So the only way you can have it on both is if they physically have it on both.
Okay.
So in front just makes you choose. Gives you options. So I always just put on the top number. Yeah. Only if you use it when it was not appropriate. Yeah. True. Well, that's why you can't just suck up my oxygen. You have to actually work. Yeah, I would don't realize if they start calling anything like this, go get it in the water. My kid, he fell asleep like constantly 3 years ago. I was like, okay, when you fall asleep, you he's like, no, you're going to leave them like this information. I'm like, I didn't get out of social. I like sleep through all. I'm like, freaking run and get some water and come back and see if I can get it. He's like, but I'm missing, like, I'm missing, you got to sleep for 10 minutes. Or pass out, like, you look snoring. I don't want to. I didn't like it. You're vicious. Like, this is not a good guy. I'm going to call it out where it is. Where are you again? Oh, from the HD. Have a good day. Oh, have a good day. Have a good day. Have a good day.
Alice here to the front office, please.